Good morning. This is your stats sensei, Mr. Spensei, and we're going to go over the quiz. Please remember this will be probably your best review for your test on Monday. So during the flu vaccine shortage in the United States, it was believed that 45% of the vaccine eligible people received the flu vaccine. The results of a survey given to a random sample of 2,350, so that's our sample size, N, um, vaccine eligible people indicated that 978 of the 2,350 had received the flu vaccine. So this would be our X, this is our N, this is the initial claim, so this is the true population proportion. Construct a 99% confidence interval for the proportion of vaccine eligible people who had received the flu vaccine, given interpretation of your confidence interval and of the confidence level. So this right here is our confidence level, and it's asking us for or asking us to create a confidence interval. Well, when we go to the very first step is to define our parameter. So our parameter is the true population proportion. So let P equal the true population proportion. What are we looking for the proportion of? We're looking for the proportion of vaccine eligible people who received the vaccine. So let P equal the true population proportion of vaccine eligible people who received the vaccine. All right, so that's what we're looking for. All right, our conditions. The very first one was really easy. It was random sample. And they gave us that to us. They told us up there in the prompt. Random sample given. We can check that off. The next thing, we're working with proportions, and I need to see it like this. When we're working with a confidence interval and with proportions, we're going to need n times p hat and n times 1 minus p hat. Well, first off, we need to talk about what p hat is, and I'm going to make a little note up here. P hat equals x over n. So p hat equals 978 over 2,350. Now, you didn't need to show this work right here. I'm just defining it for you so that we can use it. And we already said that n was 2,350. So in this case, 2,350 times 978 over 2,350 equals 978. And over here, it's 2,350 times 1 minus 978 over 2,350. And when we do that, we end up getting 1372. And both of those numbers happen to be greater than or equal to 10. So once we say that, we're going to have to say, okay, to use the normal approximation. So then I need to write the formula. And my formula is just simple p hat plus or minus z star. And again, I'm copying this straight off of the recipe card. P hat times 1 minus p hat all over n. Make sure you put the square root sign. Next thing is it asked for is x. Well, we already said x was 978. N is real easy. That's 2,350. and this is 978 over 2,350. And we also have the confidence level of 0.99. And I should make a comment about my conditions and about this right here. If you leave it as a fraction, that's great. If you wanted to turn them into decimals, that's fine as well. So if you want to use a fraction here, that's great. If you want to turn it into decimals there, that's fine as well. So now we need to calculate Z star. And hopefully my calculator is going to show up. Well, Z star, we go to second, followed by vars, inverse norm. And we're going to go parenthesis 1 minus 0.99 divided by 2. All z-scores have a mean of 0 and a standard deviation of 1. And I end up getting 2.5758. I like to make it positive 2.5758. Okay, there's our z star. The next thing we need to do is we just need to plug into the formula. And once again, when we plug in, we can plug in using fractions, or we can plug in using a decimal, whichever you prefer. And just to help things out for explanation purposes, 978 divided by 2350 gives us a decimal of 0.4161. All right. So I could use 0.4161 plus or minus z star, which is 2.5758. And then we have 0.4161. And again, if I wanted to use the fraction, I could. 0.4161 times 1 minus 0.4161 all over n, and n was the 2,350. All right, at this point, we're ready to go ahead and run this thing. So I'm going to run this fairly slowly. So we're going to go stat, arrow over to test, and we're going to run a 1 proportion z interval, which happens to be letter A, and our x is 978, our n is 2350, and our confidence level is 0.99. And I end up getting this as my interval. So my interval is 0.3899 and to 0.44236. All right, so what are we? Well, we are 99% confident that the true population proportion of vaccine eligible people who received the flu vaccine lies within the interval 0.3899 to 0.4423. By the way, I didn't have to put the 6 on the end. All right. Should have stopped it right there. So I'm just going to just do that right there because we only need 4 decimal places. Okay. So that takes care of number 9. And then number 10 is in repeated sampling, we expect to capture the true population proportion of vaccine eligible people who received the vaccine. How often? We expect to receive it 99% of the time. Right. So that takes care of the confidence interval. So now we need to go and move over to the hypothesis test, which means we probably should go read the scenario because I did change the numbers. So during a flu vaccine shortage in the United States, it is believed that 45%, once again, this is our population proportion, that's our claim or PO, percent of vaccine eligible people who received the flu vaccine. The results of the survey given to a random sample of 2,350 vaccine eligible people indicated that 1,008 of the 2,350 had received the flu vaccine. Is there evidence at the 3% level, so this is our alpha, that the proportion of population receiving the vaccine is less than 45%? Awesome. So we're dealing with a less than, so our HA is going to be less than, and our claim is going to be 45%. So when we go about writing that up, the very first thing we have to do is write our null and alternative. So our HO, P equals 45%. You can put the 0 there or not, that's up to you. Then we have HA, P, and they told us less than, so less than 45%. Alternatively, you could have written it like this: HO, P equals 0.45, HA, P is less than 0.45. If you write it with this without the percent sign, you better have the decimal. So one of these two ways would get you full credit. So we got to define the parameter. Well, guess what? It's the same as what we had earlier. So this is going to be the same as what we had for the confidence interval. So let P equal the true population proportion of vaccine eligible people who received the flu vaccine. All right. Conditions, random sample. Well, they told us up here, random sample. So random sample was given. And then we need to make sure that our sample size is large enough. Well, remember on the other side, we use NP hat, but here we have to use NP and N times 1 minus P. So this has to be, so what does this equal? Well, N was 2,350 and P is 0.45. And over here, 2,350 times 1 minus 0.45. Now, please notice the difference. This side we're using P, and this side we're using P hat. And I will count off if you did this wrong. All right, so this was P hat on the confidence interval, but on a hypothesis test, you're having to use P. And I know that's a little bit confusing, so be careful there. So 2350 times 0.45 is 1,057.5. and 2350 times parenthesis 1 minus 0.45 or 55% is 1292.5. Both are greater than or equal to 10. So I've done that, but I need to leave the phrase okay to use the normal approx. All right, our formula. And a lot of people had a little error on this. So this is z equals p hat minus p over, make sure you have the square root sign. A lot of people left that off. P times 1 minus p over n. Make sure this is p down here. All right, make sure you have p on this side. Whereas on this side, when you wrote the formula, you had p hat. Make sure you make those differences. All right, the graph. This was another area that people goofed up on. Well, the graph is centered at P. So here's my graph. It's centered at P. And P in this case is 0.45. Well, I need to know what P hat is. Well, P hat equals X over N, which in this case was 1008 divided by 2350. 1008 over 2350. And no, you didn't have to show this there. I'm just doing it because it's convenient for me. 1008 divided by 2350 equals 0.4289. So this equals 0.4289. Well, that means it's down here. This is 0.4289, and this is P hat. And we're shading this way, and this goes to negative infinity. All right, so your graph needs to look like that. You should have P, you should have P hat, but most importantly, it needs to be centered at 0.45, and I had to have that value. If you wanted to leave it as a fraction, I accept it as a fraction, but I think it's better as a decimal. So over here, P hat, X we said was 1008. N we say is 2350. P hat is 1008 over 2350, or as a decimal, either way. And P is just plain old 0.45. All right. So then we need to plug into our formula. And so Z equals, and I need the Z in front, is 0.4289 minus 0.45 over, don't forget the square root sign, a lot of you did. This is 0.45. This is 1 minus 0.45. And N is 2,350. All right, so we need to run the test. So at this point, stat test, 1 proportion Z test. P is 0.45. And now we have 1008. And this is 2350. We need a less than. A lot of you had the wrong sign. Remember, whatever sign you have here has to match there. So if this was a less than up here, then this needs to be a less than on a calculator. A lot of people lost points for that. So we ended up getting a Z of negative 2.0525 with a p-value of 0.0200. All right, up above, we said our alpha, our significance level was 3%. So we have 0.0200, and this is 0.03. We make them the same length. This is less. Because our p-value is less than alpha, we reject the null. And our p-value is 0.02. Our decision, we reject the null. There is sufficient evidence at alpha equals 0.03 to suggest that the true population proportion of vaccine eligible people who received the flu vaccine is HA. Well, what was HA? Oh, less than 45%. HA is less than 45%. We just need to put it in words. Make sure you use words. If you use symbols, it's wrong. Is less than 45%. The part that has to be in words is this part. If it's greater than, use greater than. If it's not equal to, use the word different. All right, so things to be worried about. Make sure you use the square root sign. Make sure you use the graph and label it centered on the P, and make sure you have your P hat either above or below, depending on what it is. Make sure that when you're using your sample, when you're checking for sample size, you're using P here, all right? Next thing is on the calculator. Make sure whatever symbol, when you run the test, make sure the symbol you have here is the symbol you have on the calculator. Again, I know what they have on the calculator doesn't really make sense, so ignore it. You go one proportion z-test, and then you go, oh, I see, I wrote less than. If you wrote less than, you use the less than. If you have a greater than, then use the greater than. Don't just ignore what they have as far as the P and the P naughts. Just sit there and notice, make sure those things match. All right. I hope this helped, and I hope y'all all make hundreds on your test on Monday. All right. Thank you. This is your Stats Sensei. Hope to see you on the next one.